Welcome to the Ruckus Associates Smart Zone Administrator demonstration series for the SmartZoneOS5 release. In this course, we will show you the functionality of SmartZoneOS5 along with the basic configuration of many aspects of the controller. In this particular video, we will provide you details on configuring wireless LAN within the SmartZone, including its basic and advanced options. So let's get started. So the objectives for this particular video is that we're going to take a brief look at some wireless LAN considerations. We're also going to look at the wireless LAN options that are available to you configuring in SmartZone, and then we'll look at the basic and advanced wireless LAN configuration options that you have. While planning and considering configuring a wireless LAN, there's a few things that you need to think about when doing so. One is, how will the users authenticate? Or, what type of encryption should be offered? And should the traffic be tunneled, such as going back to a corporate headquarters where you can add additional value added, such as VoIP or proxy or other features that need a tunneling back to a central location? Now, this list by no means is complete. However, it provides you a good starting point for what kind of things that you need to consider when configuring a wireless LAN. So let's take a look at the wireless LAN options while we go through the process of configuring a wireless LAN within SmartZone. So now we are in SmartZone. We are going to go from the dashboard where we are currently at into the wireless LANs tab. So we're going to click on that. And then we're going to see the domains that we have configured here. So we have a partner domain as well as a subdomain and then a zone within that domain as well. So we're going to click on that Team X zone domain that we have created, and we're going to click on Create. Once we do that, we see that we have the Create Wireless LAN Configuration options in front of us, and the first things we're presented with is the name SSID, as well as the zone that we want it configured in and the wireless LAN group that we want it associated with. So we're going to go ahead and configure the name first here. So I'm going to put in our Team X standard, because that's what we're configuring today. Notice when I leave that group or that field, it automatically populates the SSID. Now this is not a mandatory thing that you have these two fields the same, but it's just a handy feature because normally the name that you have associated with this particular wireless LAN is going to carry the SSID value. Now, once we have configured the SSID and the name, we're going to look at and verify the zone that we want this dropped into. Now, because I selected and pre-selected the zone before I pushed the Create button, we see that I automatically put it in this zone. However, if we did want to have it in a different zone or a different area within this particular configuration, we would go in this particular option and be able to choose a different zone or a different area in which we want this wireless LAN associated with. Same goes for the wireless group or the wireless LAN group. We haven't talked about those, or you might not have seen that demonstration for wireless LAN groups yet. But in addition, you can select the wireless LAN group that you want this particular wireless LAN to reside as well. Now, as you can see also, we have the general options, which is what we just filled out. And then you have authentication options. We have encryption options. We have the data plane options, accounting service, some additional options there, and then as we continue to go, we will have the radius and advanced options as well. So let's go ahead and move on to the next tab or the next option here, which is authentication options. So in this demonstration, we're going to concentrate on the standard usage as well as the open method when it comes to configuring a wireless LAN. This is by far the most common, especially when it comes to standard usage and when it comes to open as well. Now we have the method of open, which we are going to concentrate on, but we have additional options such as the 802.1x, which would require us to add authentication methods, allowing those particular users when they're trying to connect to authenticate against some type of service. We also have the option of MAC address, where we can associate a MAC address of those devices as they're connecting, and then we also have the 802.1x and MAC. So these are a couple of options that are a little beyond this demonstration, but do know that those are available for you to be able to configure and customize this based on the needs of your environment. Now, once we have looked at that method, we're going to go down to the encryption options. So as you can see, the default from the encryption options is none. So if you choose the encryption method, the additional settings for each method will become available, as you can see as I start selecting. So we're going to click on WPA2 right here. So in this particular case, it's going to ask me or requires that I put in a passphrase. Now this is going to be the passphrase that people use when they're trying to connect to this wireless LAN and use this service. Now once I've configured that passphrase, you can see we have additional options that we can choose from, such as the 802.11r, which is known as fast roaming, and this is a common advanced setting that is used for VoIP deployments. Now we also have the 802.11w, which offers management and frame protection, and that R and W, as mentioned, are advanced topics and they're beyond the scope of this particular course, but do know those are available to you to choose if you so want to. Now the next option you see is the dynamic PSK, which dynamic PSK is an internal dynamic pre-shared key that can be generated and maintained within SmartZone by navigating to the client's dynamic PSK area. Once a zone is selected, the Generate DPSK will be available to populate. Once generated, each DPSK will be displayed along with the type and status. Now there's three kinds of DPSKs. There's the unbound, which is where DPSK is not binding to a specific device yet. So once an unbound DPSK is used by the device, however, it will become bound to that DPSK and release one slot from the maximum limit of 320. Now the group DPSK, which is known as the DPSK that can be shared between devices instead of being committed to a single user device. Now a group of DPSK will never become bound. It will always occupy one slot from the 320 limit until the admin basically will delete that. And then finally, the third is a bound DPSK, which is where a DPSK is bound to that specific device. Now, an admin can import the bound DPSKs using a CSV by specifying the MAC address and create bound DPSKs regardless of the 320 limitation. A sample CSV can be downloaded and then populated and configured and then imported for the use for that particular wireless LAN. So in the encryption options section, we're only going to set the passphrase with WPA2 and keep the other items disabled for now. So the next section that we can look at is the data plane options. Now the data plane options gives us the ability to either offload, which is the default behavior, to a local WAN, or we can actually set up a tunnel, allowing this traffic to be sent back to a central location, allowing it to be offloaded there, adding additional features and options when it comes to the traffic that is being traversed over this network. Let's look at the effect of enabling a tunnel for a wireless LAN. Without tunneling, an access point passes traffic straight to the internet. This is normal for most deployments. However, there are occasions where the traffic or security policies require the traffic to be sent to a controller. VoIP is probably the scenario you will most be familiar with, where connections require fast BSS transitions. You may also want to use tunneling in conjunction with data monitoring. In order to enable a wireless LAN tunneling at the wireless LAN level, you need to have already configured a tunnel interface, either a physical interface or a virtual data plane. You also need to have a tunnel profile created under the Services and Profiles, and then Tunnels and Ports. You can enhance tunnel configurations with additional settings. Check the Administrator's Guide and the Ruckus website for more information about tunneling. Now the tunnel selection for wireless LAN you can find under the data plane options, allowing you to set up tunneling for the wireless LAN traffic. The default is disabled, as you just saw, and that is the traffic is not tunneled and performs local breakout forwarding. To enable tunneling, you can select the tunnel wireless LAN traffic through GRE tunnel to forward the traffic from the wireless LAN back to the controller. When tunneling through the Ruckus GRE tunnel, additional core network options include core network, data plane DHCP/NAT options, and if you're using a virtual SmartZone instance, a Flexi VPN data plane profile option is available as well. As mentioned in earlier modules, each AP can support soft GRE tunnels to external GRE gateways. To use these, the soft GRE tunnels need to be configured and associated with the zone. In this scenario, the controller functions purely as an AP controller managing the Ruckus APs and does not perform other functions, such as control paths, as in radius authentication and accounting, and data plane paths, such as soft GRE tunneling, which instead terminate on a third-party wireless LAN gateway. 3 soft gateways can be configured for each zone along with a Ruckus GRE where one of those options can be associated to a wireless LAN using these drop-down menus. One soft tunnel, however, can be assigned and associated with a wireless LAN if IPsec is required for the tunnel. The next option that we have going down is accounting service. As you can see, by default it's disabled. However, this can be enabled where we can send accounting messages out to an accounting service. We have 2 options when it comes to how this is going to be performed. One is using the controller as a proxy, as you can see here. That means when this proxy is enabled, the accounting messages are going to be sent by the controller. However, if we have this off, it will be a non-proxy mode where the AP will communicate the accounting messages directly to the accounting server. If we want to enable this service, we can go down and select in this list, or we can go and configure one by clicking on the plus button here. Moving down, we can see our next option is for wireless client isolation mode. That is disabled by default by standard wireless LANs, but it can be enabled on other wireless LAN types. A best practice is to always check the settings. So the option to disable is where devices are able to see all other devices on that particular subnet. However, if we enable it, that means devices that are connecting will be blocked from seeing other devices on that VLAN or that subnet. So customized access allows you to control what devices users can see or access, such as a specific printer or a portal. So customized access using the isolation whitelist option allows you to control what devices users can access, such as specific printers or a portal. You can customize the device access through configuring the user traffic profiles, UTPs, and those are discussed in the Managing Wireless LAN Devices module in this course. You can also select a priority of the client traffic, which as you can see is set to high by default. Priority relates to the SmartCast traffic quality of service. The default for all wireless LANs is high. You may select low if you are working with advanced QoS settings and want to influence network traffic. However, this is an advanced subject. If it's something you're interested in, you should refer to the Ruckus website for more information on SmartCast. The next option we have is radius options. Radius options determine the controller's behavior when the primary radius server is unavailable. Use these settings as part of your radius redundancy strategy. The NAS ID defines the ID sent to the radius server, which will identify the AP. NAS request timeout is the duration in seconds after which an expected radius response message is considered to have failed. The NAS max number of retries is the maximum number of failed connection attempts after which the controller will fail over to a backup radius server. The NAS reconnect primary is the time interval after which the controller will recheck if the primary radius server is available when the controller has failed over to the backup radius server. Called STAID indicates the format of the called station ID, which is sent to the radius server as an attribute and can be used in policy decisions. Single session ID accounting feature is set on by default and allows the APs to maintain one accounting session for the client when roaming between APs. If the client roams from one AP to another, the accounting session ID and stats will be carried while roaming. If the feature is not enabled, the accounting session ID is regenerated and the stats are also reset. Wireless LAN Advanced Options. Within the wireless LAN configuration, under the Advanced Options, you will find a range of additional settings that give you a high degree of control over the way your wireless LAN functions. The first three options you will see here is the User Traffic Profile, the Layer 2 Access Control, and the OS Policy. So under User Traffic Profile, this is used to allow or block traffic based on Layer 3 or higher protocols. The Layer 2 Access Control allows for the block of devices based on the MAC addresses. And OS Policy allow you to apply a policy based on the device type and can be identified by the operating system that it's running on. You can add an existing policy or create one here, and the policies are stored under the Services and Profiles and then Access Control. Now the next option that we have is the Application Recognition and Control. This is disabled by default. However, I'm going to enable it for our particular wireless LAN here. And once enabled, the controller can identify the applications in use on the client's devices. You can see the applications that are used within the dashboard and also see which applications are being most used within the environment or this wireless LAN. The next option you see is URL filtering. With the URL filtering feature, you can enable to block access to inappropriate or undesirable websites. The web pages available on the internet are classified into different categories, and those identified can be blocked based on available categories. A third-party cloud-hosted URL categorization service called WebRoot BrightCloud URL Categorization is used to categorize the live web traffic generated from the client's devices. Administrators can create policies based on these categories and allow or deny users access. Once a URL filtering is enabled, the profiles can be selected, created, or edited by selecting the options to the right of the profile field. Filtering can be identified by categories. Black or white lists and safe search options are available as well. URL profiles can be accessed through the Services and Profiles, URL filtering, and then Profiles within SmartZone. URL filtering requires a separate URL license which can be added over time. Please refer to the SmartZone Administrator's Guide for more details about URL filtering and licensing. The next option we have down is known as Wi-Fi calling. Now the Wi-Fi calling works with smartphones that have the ability to connect to their carrier and establish calls through the local Wi-Fi connection by establishing an IPsec tunnel for their Wi-Fi calling feature. A wireless LAN can be configured to auto-detect and prioritize the voice traffic over other network data traffic. The detection is based on the common Wi-Fi calling port and the DNS configured values. Multiple fully qualified domain addresses along with a priority can be configured for each carrier. Pre-configured profiles for your carriers can be added to this particular wireless LAN. However, in this case, when none have been configured, we can actually go up and configure them by clicking on the plus sign. Each carrier can have a profile configured within SmartZone, allowing us to prioritize their particular Wi-Fi calling based on the voice, video, best effort, or background. Once we have assigned that, we will go into the Evolved Packet Data Gateway and assign the fully qualified domain names. Domain names are required, however, the IP address is optional. Up to 4 fully qualified domain names can be assigned to a profile, so you can add those for a particular carrier and then assign this to the wireless LAN. You can see now that policy is available to us to add it to the wireless LAN. Now, any calls going to that particular carrier's fully qualified domain name listed in the policy will be handled in the QoS manner we have chosen. Each one of these calling profiles can be changed and monitored if you go underneath the services and profiles of SmartZone and then Wi-Fi calling. Now the next option we have in the wireless LAN configuration is the client fingerprinting. Client fingerprinting enables the system to identify the client's devices by operating system. This feature is enabled on a per wireless LAN basis and is enabled for all new wireless LANs by default. When enabled, client fingerprinting works as follows. First, the client fingerprinting is enabled on the wireless LAN. Next, the access point will attempt to identify the OS in use on the device. Lastly, the controller displays the client OS types in the dashboard. The next option is the Access VLAN. The Access VLAN tags the wireless LAN traffic with the VLAN ID. This can be between 2 and 4094. Now by default, all Access VLAN client traffic will be assigned to the native or untagged VLAN on the AP's Ethernet port, which will be represented as a VLAN ID of 1, as you can see, which is pre-configured here. Now, wireless LAN pooling is used in situations where you want to have a high number of clients connecting to the wireless LAN, but want to restrict the size of the IP domain. VLAN pooling uses a VLAN pooling profile, which can be created here. Or you can go and configure or edit any ones that are pre-configured here, or you can go and edit these as well underneath the services and profile, access control, and then VLAN pooling. To create a VLAN pooling, you can simply click on the plus sign here, and it will pop up asking for a name, the VLAN pool profile description, and the VLANs that you want associated with this. VLANs that are configured within the VLAN field will allow devices that are connecting to randomly have a VLAN assigned to it based on a MAC hash system. The next option we have is hiding the SSID option. Now, hiding the SSID is an option that is disabled by default, as you can see here, and this feature has a limited security value, but it is useful to know how it works. Now, hiding the SSID removes the SSID from the beacons. Access points that receive the null probe request from the clients will ignore the requests. However, if a client sends a probe request and the SSID specified, the access point will respond. The association request frame itself contains the SSID, so you can see that finding the hidden SSID is not too difficult. You can see our next option is client load balancing. So if you want to disable it for specific wireless LAN, such as the one we're configuring here, you can do so right here. Now below the client load balancing is the proxy ARP option. This allows the access point to act as a proxy for the ARP request from the client. Now, although this does reduce wireless LAN traffic, you should only use this if you have a good understanding of network protocols, and you should know this feature is required. Next is max clients. This allows you to set the upper limit of clients to associate with the wireless LAN. Capacity planning is an important understanding, and again, you should have a good understanding of wireless LAN operations before using this feature. Next is enabling 802.11d, which adds support for additional regulatory domains. A simple way of describing 802.11d is that it allows devices to understand the country they are in and operate without reconfiguration. And as you can see, 802.11d is enabled by default. 802.11k, which is the neighbor report, is also enabled by default, as you can see. A compliant client is able to request a neighbor report. The access point will respond with information on nearby access points that the client may roam to next. 802.11k works best when configured with corresponding 802.11 applications. Our next option is to force DHCP disconnect clients that do not request an IP address. This feature is used to block devices with manually configured IP addresses that may be in a different range to the one used for the wireless LAN. As you can see, this feature is disabled by default. DHCP option 82 supports DHCP relay and is disabled by default as well. Now the client TX and RX statistics is enabled by default, and you can check this to ignore the statistics from unauthorized clients if you so choose to do so. The inactivity timeout specifies the amount of time before inactive clients are disconnected. Now the next settings we see affect the data rates that are on the wireless LAN. These settings can have a major effect on how the wireless LAN operates. You should have a good understanding of the wireless LAN operations and a solid functional reason to change these settings, and you must monitor and analyze the results. The OFDM only disables the DSS and HRDSS rates from the wireless LAN and will operate using only OFDM. This setting only affects the 2.4 GHz radio, causing the 802.11b devices to disconnect by forcing them to use the higher data rates for the more efficient airtime usage. OFDM is used by 802.11a, G, N, and AC, but is not supported in the 802.11b. As you can see, it's disabled by default. The BSS minimum rate sets the minimum data frame transmission rate. OFDM only takes the higher priority over BSS min rate. The management transmit rate sets the transmit rate for management frames. If OFDM only is enabled, this option is not available. Keep in mind that the 5G radio does not support CCK rates 1, 2, 5.5, and 11. Our next option is time schedule. Now all wireless LANs that you create by default are set to always on. You can disable the wireless LAN here, and if you'd like the wireless LAN to operate only during set times, you can add a wireless LAN service schedule. We will look at schedule profiles later, but you can see here is where you can either select one from the drop-down list if it's already pre-configured, or you can simply configure one by pressing this plus sign. Our next option is band balancing, which allows you to override the global settings for the band balancing and disable this for the wireless LAN. The QoS map set allows you to customize QoS settings. This is an advanced undertaking and is outside the scope of this particular course, however. The SSID rate limiting imposes a rate limit on the devices using the wireless LAN. You can also impose rate limits using the user traffic profiles and device policies. However, in order for these to function, you need to have an SSID rate limiting policy disabled. Next is the DNS server profile. By creating a DNS server profile, you can specify the primary and secondary address of the DNS server that is used in place of what otherwise is configured as a DNS server. The profiles can be created under the Services and Profiles, Access Control, and DNS Services. In addition, if it's pre-configured, as you can see, you can select it here, or you can create one here by pressing the plus sign as well. Now, if you want to log the client's flow data, you can do that by enabling this option here. Now, do know when you do this that external log servers need to be configured and enabled for client flow data logging. Now, when this is enabled, it sends a log message with much of the data information of that packet, such as the source MAC, destination MAC, source and destination IPs, source and destination ports, and so forth. Configuration of an external syslog can be found under the Systems, the General Settings, and then Syslog. The Enable Syslog feature under the zone for which the client is logging is configured and is required to be enabled for this function to work. More details about this feature can be discussed in the zone configuration module contained in this course. The next option is airtime decongestion. This feature optimizes the Wi-Fi management traffic in the network where the amount of management traffic can potentially consume a significant portion of airtime, thereby reducing the amount of time available for traffic. This feature controls the RSSI threshold setting for the transient client management. Enabling this feature disables the RSI threshold configuration in transient client management. To ensure proper function, confirm that the background scan is enabled. So once all your options are configured, you simply push the OK. And once you've pushed OK, you can see that your wireless LAN is now listed within the zone that you have configured it for. Any edits or changes that you would like to make to that wireless LAN, you can simply click on the wireless LAN, click on Configure, and you can make any of those changes that you want to. Once that wireless LAN is configured as well, it will associate and update the configuration on any APs that are associated with that particular zone as well. We can also see now that we go to a device, that wireless LAN is now being broadcast within our area. Thank you for taking the time of watching this video about wireless LAN configuration within the SmartZoneOS5. Please make note of the other videos within this series, giving you more information about the SmartZoneOS5 release. Thanks for watching.